So in part A of this problem, we are given a round-robin tennis tournament in which we start with some number of players, let's say n players, and just suppose n is a power of 2. Now, so n players. So the way round-robin works is in each round, these players pair up, and the winner proceeds to the next round, the loser is eliminated. So in each round, there are n over, so each round has n sub r over 2 matches, where n sub r is the number of players in the rth round. Why is that? Because the n sub r players have to pair up for a match, and so there are nr over 2 matches in a given round. Now, half of them get eliminated, half of them proceed to the next round. So the question is, how many rounds are there until the winner is determined, until there's only one player left? Now, we can see that at the end of each round, the number of players gets divided by 2, because only half of the players proceed while the other half get eliminated. And so the same happens in the second round. Half of the players left, half of the players, the half that won their matches, will proceed, while the half that lost gets eliminated. And same goes in the next round. The half that lost gets eliminated, the half that won proceeds. And so the question is, how many times can we divide this n by 2 until we get 1, until only one player is left? So how many times can we divide n by 2 until only one player is left? And that number is, of course, logarithm base 2 of n. So this here is the number of rounds, logarithm base 2 of n, because again, each round n gets halved in each round. So in part B, we're asked how many matches are there played in total. Well, let that be a function of n. And so in the very first round, we have n over 2 matches, because we start with n people, they got paired up, so we have n over 2 matches. Now in the next round, these n over 2 people that had won in the first round, now they get paired up. So now we have n over 4 matches, right? We start with n over 2 people, they get paired up for matches, so there are n over 4 matches. Now these n over 4 that win proceed to the next round and get paired up. So now there are n over 8 matches. And so on, until there's only one match left, right? So as we can see, the denominators are increasing powers of 2, so the question is, in which round? So what power of 2 here gives us 1? How many rounds did we say we had? Well, we said we had log base 2 of n rounds, so this is going to be 2 to the log base 2 of n. So we can write this in summation notation, we can even factor the n out. Write this in summation notation. I starts from 1, goes to log base 2 of n. And we have 1 over 2 to the power I. So this summation here equals n minus 1 over n, which gives us n minus 1. Now, if you're unsure about the summation equaling n minus 1 over n, this isn't really the crux of the problem. This isn't really the counting portion, so you can plug this into something like Wolfram alpha, and it'll give you n minus 1 over n. So the n minus 1 is the number of matches played in total. And part C says, can you figure that out? Can you figure that out that there were n minus 1 matches played in total without doing any of these calculations? Well, notice something. Notice that to find the winner, we need to eliminate n minus 1 people. Right? We started with n people. To be left with just the winner, n minus 1 of them need to be eliminated. Now, notice that for every match, exactly one person is eliminated. Right? In every match, one person exactly gets eliminated. So how many matches need to be played for there to be only one person left? Well, n minus 1 matches need to be played so that n minus 1 people get eliminated until we're left with just the winner. So the total number of games, total number of matches is n minus 1.